We are asked to find the derivative of the following function using the chain rule formula. Now, I told you in our previous class that chain rule is used to differentiate a function that has another function in itself. Okay, so let's start with the first question. Let y equals to x squared plus 1 over x. You understand? Now, in differentiating this function using the chain rule formula, the first step is that you have to set the inner function equals to a letter. Look, the inner function is the function inside the bracket. X squared plus 1x, x squared plus 1 over x is the inner function. So let u equals to x squared plus 1 over x. In that case, that means y will be equals to u squared. Do you understand? The reason is because I've already set u equals to this. That means that y will be equals to u squared. Okay? Now, the next step is to take the derivative of both u and y. Now, you know u can be written as x squared plus x raised to the power of negative 1. According to the law of indices, 1 over x is also the same thing as x raised to the power of negative 1. Okay? Now, let's differentiate the u all over the x is equals to 2x plus negative 1 times x raised to the power of negative 1, negative 1. That means I'm going to have the u all over the x is equals to 2x plus negative x raised to the power of negative 2. Okay? That means the u all over the x is equals to 2x minus x raised to the power of negative 2. Okay? Now, let us proceed to that y. Let us differentiate y equals to u raised to the power of 2. Y, dy all over du will be equals to 2 times u raised to the power of 2 minus 1. Dy all over du is equals to 2u. Okay? Now, according to the chain rule formula, the chain rule formula is given by this. Dy dx is equals to dy all over du multiplied by du over dx. See, dy over du is what? 2u. Dy all over du equals to 2u. And du over dx is what? 2x. Du over dx is equals to 2x minus x is equal to negative 2. Now, dy all over dx is equals to 2u times 2x raised to the power of negative 2, negative x raised to the power of negative 2. Okay? Now, don't forget that u equals to what? X squared plus 1 over x. So I'm going to have dy all over dx is equals to 2 multiplied by x squared plus 1 over x multiplied by 2x minus 1 over x squared. Do you know how I got this? Listen. What I did is that x raised to the power of negative 2, according to the laws of indices, can be written as 1 over x squared. You understand? So that is how I got 1 over x squared. So I've not done anything. The next step is that in an attempt to help us to simplify this solution, I'm going to take the LCM of both brackets. Okay? Let us take the LCM of each bracket. So I'm going to have dy all over dx is equals to 2 into bracket. What is the LCM? The LCM of this, the LCM of x and 1 is what? X. X divided by 1, x. X times x squared, that was x raised to the power of 3 plus x divided by x is 1. 1 times x, that is what? Oh, sorry, x divided by x is 1. 1 times 1 is 1. So I'm going to have this. Okay? What is the LCM of 1 and x squared? That is x squared. X squared divided by 1, x squared. X squared times 2x, that is what? 2x raised to the power of 3. X squared divided by x squared, that is 1. 1 times negative 1, that is negative 1. Okay? So I'm going to have dy all over dx is equals to 2 multiplied by, now let us take the product. X squared times 2x, okay, x cubed times 2x cubed, that is what? 2x raised to the power of 6. X cubed times negative 1, that is what? Negative x cubed. Plus 1 times 2x cubed, that is what? Plus 2x cubed. Plus 1 times negative 1, that is what? Negative 1. This all over x times x squared, that is what? X raised to the power of 3. Okay? So dy all over dx is equals to 2 into bracket 2x raised to the power of 6 minus x cubed plus 2x cubed. That is what? Plus x cubed minus 1 all over x raised to the power of 3. Okay? Now, having gotten to this point, let me erase. Please just pay attention, okay? It's simple. I'm very sure you understood it to that point. If you didn't understand, let me know in the comment section, okay? Now, here I'm going to have dy all over dx is equals to 2 multiplied by 2 multiplied by 2x raised to the power of 6. That is what? 4x raised to the power of 6 plus 2x raised to the power of 3 minus 2 all over x raised to the power of 3. Okay? Now, I want to erase this. So from here, dy all over dx is equals to 4x raised to the power of 6 all over x raised to the power of 3 plus 2x raised to the power of 3 all over x raised to the power of 3 minus 2 all over x raised to the power of 3. Okay? Dy all over dx is equals to, see, what I'm doing now is that I'm simplifying, you understand, to make my answer simple as much as possible, you understand. I'm trying to simplify the answer. So here I'm going to have 4x raised to the power of 6 divided by x raised to the power of 3. That is what? X raised to the power of 3. Because according to the laws of indices, if you have x raised to the power of 6 all over x raised to the power of 3, you're going to have x raised to the power of 6 minus 3, which is what? X raised to the power of 3. Okay? That's why I got 4x raised to the power of 3 plus 2 minus 2 all over x raised to the power of 3. So that is the solution to that question. The derivative of y equals to x squared plus 1 over x squared. The derivative is 4x raised to the power of 3 plus 2, then minus 2 all over x raised to the power of 3. If you get that answer, you are correct. Okay, so let's proceed to the second question. Okay, so we are asked to differentiate in 3x plus 4. Now, let me give you an hint in an attempt to help you to differentiate this function. The first step is that just set y equals to in 3x plus 4. Now, if you have to differentiate a function that looks like this, y equals to in u, the derivative of y equals to the derivative of u multiplied by in u. You understand? See, you have to differentiate the power to which the Euler's constant is raised to. This e that you see here simply means Euler's constant, okay? Now you have to differentiate this power, then you have to multiply the power by the function itself. You understand? So in that case, I'm going to set u equals to the power. Are you there? Let u equals to the power. The power is what? 3x plus 4. So I'm going to have 3x plus 4. That is u. That means y will be equals to in u. Okay? Now, du all over dx is equals to 3. Okay? And dy all over du is also the same as in u. Okay? So, dy all over dx is equals to dy all over du multiplied by du all over dx according to chain rule. So, dy all over dx is equals to dy du is what? In u multiplied by du dx. Du dx is 3. So, that means that the derivative will be 3 e raised to the power of u. U is what? 3x plus 4. So I'm going to have 3x plus 4. That is the final answer. Now, I want to give you an hint. With respect to what I wrote here earlier, if you are asked to differentiate a function that has an Euler's constant, let's say you are asked to differentiate e raised to the power of 4x squared. The derivative will be, just differentiate this power, okay? Then multiply it by the function, okay? So the derivative will be, differentiate 4x squared. That will be what? 8x. So the derivative will be 8x e raised to the power of 4x squared. If you are asked to differentiate e raised to the power of 2x squared plus 1, the derivative will be, just differentiate this function, okay? And multiply it by the function, okay? Just differentiate 2x squared plus 1. The derivative of 2x squared plus 1 will be what? 4x. So that will be what? 4x e raised to the power of 2x squared plus 1. That is the derivative. Now, I want you to attempt this. Differentiate e raised to the power of x squared plus 4. The derivative would be what? You can drop the answer in the comment section, okay? So let us proceed to our question. Let us proceed with our question. So anytime you are differentiating a function that has an Euler's constant, all you have to do, just take the derivative, okay? I just use this long step to show you that it is still chain rule that we are using to differentiate the function, okay? That is why I go this long way. But if you came across this type of question in objective, just differentiate the power to which the Euler's constant is raised to. Differentiate it, then multiply it by the function. You understand? The function, the entire function is this. This is the entire function. Are you there? Now, just differentiate the power, 3x plus 4. Differentiate 3x, you're going to have 3. Then multiply 3 by e raised to the power of 3x plus 4. You're going to have this. You can see. So that is the simple trick behind the derivative of a function that has an Euler constant. Okay, now let's proceed to question 3. We are asked to differentiate. Okay, question 3. We are asked to differentiate sine cube x. Now, the first step is that let y equals to sine cube x. You understand? Now, don't forget that we can write sine. If sine square x can be written as what? Sine x raised to the power of 3. Okay? Now, that means I can rewrite this as this. Y equals to sine x raised to the power of 3. Okay? Now, to differentiate this function, all you have to do is that just set the inner function, which is sine x, equals to a letter. In this case, I'm going to make use of u. So I'm going to have let u equals to sine x. That means that y will be equals to u raised to the power of 3. The u all over the x is equals to cos x. And the y all over the u equals to 3u squared. Okay? Now, having gotten the derivative of the inner function and the outer function, the inner function is the function inside the bracket, and the outer function is this. Okay? Now, having gotten their derivative, the next step is that just make use of the chain rule formula. Here, I'm going to have the y dx is equals to the y du, which is 3u squared, multiplied by the u dx, which is cos x. Okay? Hence, the y all over the x is equals to, now, what is 3u squared? 3u squared simply means 3 multiplied by u. U is what? U is sine x raised to the power of 2 multiplied by cos x. Okay? So, you can leave your answer like this and you can write it as this. 3 divided dx is equals to cos x 3 sine x squared. Okay? So you can write it as this. So that is the solution to that question. I'm very sure you'll be able to solve this one as well. All you have to do is that just follow this step, okay? And you're going to arrive at a very good answer. So I want you to do this just like follow the same step that I used here and attempt this question, okay? So that's all.